Hi, it's Professor Davis again, and this is your topics checklist for sections 5.2 and 5.3. In Chapter 5, our movement is going from the general computational rules for probability to a more predictable type. And so in Section 5.2, that section serves as an introduction to random variables. So there, we first want to be able to distinguish between the two types of random variables, discrete and continuous. And that harkens back to what we talked about in Chapter 1 when we talked about discrete and continuous data. We're now looking at that in terms of a random variable. So make sure you look over the difference between those two. And also, we want to be able to determine if a table constitutes a probability distribution. Remember, the word distribution in statistics means table. So by a probability distribution, we mean a probability table. So we want to be able to make sure the two requirements of a discrete probability distribution are met. Those being, first, are all the probability values between 0, 1, 0, and 1 inclusively, and do all the probabilities in the right-hand column of a probability distribution add up to 1. Then we want to be able to compute the mean and the standard deviation of a probability distribution. So that is something you need to practice. You can either use your calculator to help you do that, or you can do it by hand, presupposing there aren't too many values for a discrete random variable. Now notice the mean of a probability distribution is synonymous with what's called its expected value. So that make sure you look over some of the applications there for that. And the reason we're computing the mean and the standard deviation is to identify unusual probabilities. Those are values of a random variable that are more than 2 standard deviations beyond the mean. So that's where we get into that mu plus or minus 2 sigma thing as the bounds for unusual probabilities. So make sure you look over that. Then in section 5.3, that's the other section we want to cover this week. That is on the binomial probability distribution. That is a specific type of discrete probability distribution that follows 4 requirements. So make sure you look over those 4 requirements. First, does each trial have only 2 possible outcomes, success and failure? Is the probability of success fixed for each trial? Are the trials independent? And fourthly, is the number of trials fixed at some number we'll call n? So make sure you look over that. And then we want to be able to compute binomial probabilities using the binomial probability formula. So that's something you might want to practice. And going hand in hand with that, we want to be able to compute binomial probabilities using the PDF command on the graphing calculator. That's actually a very simple way to compute probabilities that are binomial in type. So in the StatCast area of the class website, you might want to scroll down to section 5.3, where I've made a StatCast on exactly how to do that. And let me make mention of one more method, and that is the tabular method using table A1 in the appendix. You'll find that in the appendix folder in the ebook. We won't be using that because that table only works for certain values for P, the probability of success. So it's really of limited use for us. We want to be able to use the binomial probability formula and our graphing calculator to compute the probabilities. So make sure you look over the StatCast for that. So for this, these 2 sections for practice exercises, starting on page 214 in section 5.2, we want to do problems 5 through 17 odd, 21 and 25. Then in section 5.3, starting on page 225 in your ebook, problems 5 through 33 odd. Then in the next sections, we'll continue with some more of the properties of the binomial distribution. But for now, that is your topics checklist for sections 5.2 and 5.3.